This is a map of where you, me, and all the 7.8 billion other humans on the planet currently live. It shows two totally different and separate realities experienced on our planet. The inhabited, populated world made up of cities and settlements of people where nearly all of us watching this video live in, and where nearly everyone you've ever met or heard of exists in. And then there's the rural, underpopulated frontiers that are still largely devoid and empty of any of us. This picture tells a million different stories, but the one I want to focus on for this video are straight lines. There are only two locations on this map where the settled world and the empty world are nearly perfectly divided by a straight, almost human-looking designed border. The first is here within the African continent, and it's obvious why it exists. To the south of the line is the African Sahel, a semi-arid belt that wraps across the continent, where rainfall is limited but still actually exists. And to the north of the line is, of course, the Sahara Desert, one of the most hostile environments on the planet to human life, where several years in a row can pass by without a single drop of rainfall, and where the average temperature can soar to more than 40 degrees Celsius for months at a time. It's no wonder that nobody lives there, but the other straight line boundary between the two different worlds of our Earth is significantly stranger, because it slices down the center of the most powerful nation in human history, the United States of America. If you zoom in more closely on it, you'll notice that this sharp division between populated America and unpopulated America follows a nearly vertical line south to north, immediately to the west of many major population centers like San Antonio, Austin, Fort Worth, Oklahoma City, Wichita, Lincoln, Omaha, Sioux Falls, Fargo, and up to Winnipeg in Canada. These are the cities that quite literally mark the boundary of the North American frontier, a fact that becomes just as obvious when you switch out the population density map for a satellite view of the United States at night. To the east of these frontier cities is a nearly continuous chain of lights, all the way to the Atlantic Ocean and the eastern seaboard. And to the west of them is but a sea of darkness, with only scattered islands of light and civilization. If you drive from the east to the west across this invisible line at any point, you will immediately notice the sharp difference in the distances between communities, gas stations, and general stores. In general, this invisible line separating the more developed east from the more rural west follows the 98th meridian of longitude, and it sharply divides the American population in half. An overwhelming 80% of all Americans, some 260 million people, live to the east of this line. And that means that the remaining 20%, or just about 1 in 5 Americans, live to the west of the line. An enormous stretch of territory that actually makes up the majority of America's land once you factor in Alaska. And weirdly, this empty part of the United States to the west of the line where only 1 in 5 Americans live includes the entirety of California, the single most populous state in the country that's home to even more people than Canada. But California is the enormous exception to the overall rule, because with nearly 40 million people, it alone accounts for around 60% of the entire American population west of the line straddling the 98th meridian. But of course, it gets even stranger because most of California's population lives within the westernmost fringes of the state, near to the Pacific Ocean. If you draw a separate line from San Diego in the south across the US West Coast through to Portland and Seattle in the north, you would find that there's around 50 million Americans who live within the narrow coastal plain between the Pacific Ocean to the west and the Cascades and Sierra Nevada mountains to the east. An isolated, albeit lengthy pocket of civilization surrounded by the darkness. Between this pocket and the 98th meridian exists a vast stretch of the American interior that covers about 1/3 of all the land in the United States and is just a little smaller than the entire European Union. It encompasses the entirety of 8 US states and a significant amount of territory from 9 more. And yet, throughout this vast expanse of land is only a mere 30 million people, or just about 9% of the American population. To put that figure into context, that's a number of people that is comparable to just the population of the greater New York City metropolitan area on the US East Coast. And then there's the fact that the vast majority of those 30-some-odd million people live within just a handful of urban oases scattered across the darkness. Around a third of them simply live within just 3 of these oases: Phoenix, Denver, and Las Vegas. More than half of them live within just the top 8 largest oases, including those largest 3 plus Salt Lake City, Tucson, Albuquerque, El Paso, and Boise. When excluding just these 8 urban oases, the rest that remains throughout the area is home to less than 15 million people, around the same number of people who live within just LA and Orange counties in Southern California. The vast majority of this huge landscape is almost utterly devoid of any human life and civilization, and it represents one of the emptiest landscapes anywhere on the surface of the 21st century Earth. As a result, the line that divides America's heavy population in the East from its nearly empty population in the West can and has been seen in thousands of different maps depicting all kinds of different, seemingly unrelated realities within the United States. And you've almost certainly seen one before and probably never even really thought about why it exists. Here it is clearly seen in the average distance from a McDonald's within the United States. Here it is again seen pretty clearly in the linguistic divide in the country between those who are more likely to refer to this insect as a firefly or a lightning bug. And here it is again in a map that doesn't even have anything at all to do with humans. It's just a map showing the diversity of tree species within the US, where the line is once again pretty clearly visible, with significantly less variety of tree species to the west of it. Even plants follow the unspoken law of this line. So what the hell is actually going on here? Why does this invisible, linear law of nature that decides so much about American society and civilization exist in the first place? To answer that question, we need to go back a few decades to the first man who ever noticed the line's reality, all the way back in 1878. John Wesley Powell. Powell was a geologist and an explorer of the American West, and the second director of the United States Geological Survey. As he passed from the east to the west, he noticed that the variety of plant species gradually diminished to the point of being nearly non-existent. He determined that this was the case because it simply rained more in the east than in the west. And the line he drew to mark the boundary between the more wet east and the more arid west was the 100th meridian line of longitude here, which was more or less correct. When you look at a modern map of annual rainfall levels within the United States, you can also more or less spot the 100th meridian line that Powell identified. As you move westwards across North America, annual rainfall decreases dramatically. Dallas to the east of the line receives 38 inches of rain a year, while Abilene over to the west of the line only receives 26 inches, and Midland even further to the west only receives 15 inches. This is a pattern that repeats itself all the way up and down the line as well. Oklahoma City gets 33.5 inches of rainfall, while Amarillo to the west only gets less than 20. Wichita in Kansas gets 34 inches a year, while Dodge City just a bit over to the west only receives 19. It simply rains a lot less to the west of the line than to the east of the line, and that simply makes sustaining life and civilization much more challenging, which is why humans and trees alike are all fewer and more scattered beyond it. A century and a half ago, John Wesley Powell correctly identified one of the geographic explanations behind this North American law of nature: the Great Rocky Mountains. They are the third longest mountain chain in the entire world after all, spanning for more than 3,000 miles across the continent, from the northern reaches of British Columbia up in Canada, all the way down to New Mexico in the south, and with peaks soaring up into the sky as high as 13,000 and 14,000 feet. These long and towering peaks effectively act like a colossal wall, blocking most of the moisture blowing in on clouds from the Pacific Ocean, and therefore preventing most rain from passing beyond them towards the arid plains of the east. This effect is called a rain shadow, and the shadow cast by the Rockies across the North American plains is enormous. But of course, there are many other geographic factors at play here as well that determine North America's straight climate line. For one, the Rocky Mountains aren't the only mountain chain on the continent that block moisture blowing in from the Pacific. There's also the Cascades stretching across the Pacific Northwest, creating in their span a clear division between the wet, rainy, and narrow coastal plain to their west, between them and the Pacific Ocean, where big cities like Vancouver, Seattle, and Portland have all been able to be established, and the drier, more arid environments found over to the east, where the moisture blowing in from the Pacific fails to penetrate into. Washington state itself could not be any more climatically different than between its west and east because of these mountains. Seattle, to the west of the Cascades on the narrow coastal plain exposed to the Pacific, receives 37 inches of rain a year, whereas the small town of Mattawa, just over on the eastern side of the Cascades, receives only 4.5 inches of rain per year, which is about the same as infamously dry Las Vegas. And further to the south in Nevada and California are of course the Klamath Mountains, the Transverse and Peninsular Ranges, and the most formidable range of all, the Sierra Nevadas, with peaks as high or even higher than the mighty Rockies themselves. All of these high mountain peaks serve to block moisture blowing into the eastern interior from the Pacific Ocean, and in effect, their presence creates only a narrow strip of land across the west coast between them and the ocean where there is suitable amounts of rainfall to sustain large-scale human population centers, running roughly from northern Washington down to the San Francisco Bay. The only reason why Southern California contains major population centers today like LA and San Diego is because they are massively irrigated and supported by a complex system of canals, aqueducts, and pipelines that bring water in from elsewhere like Northern California where it actually rains, and from the Colorado River further to the east. And so, being robbed of almost any moisture blowing in from the Pacific Ocean to the west, the continental interior of North America has very few other alternative sources for moisture or fresh water that are mostly limited to either rivers or snowmelt. Over on the eastern side of the continent, the biggest mountain range are the Appalachians, which are effectively just speed bumps in comparison to the giants of the west. The highest peak within them, Mount Mitchell, is less than 6,700 feet tall, or less than half the height of the tallest peaks that are seen in the Rockies, the Cascades, and the Sierra Nevadas. As a result, they do very little to block any moisture bellowing into the continent from the Atlantic Ocean in the east. And so, Atlantic winds frequently bring moisture across the East Coast and the eastern Mississippi Basin, enabling large-scale agriculture without any need for irrigation. But, unfortunately, these winter Atlantic storms simply don't make it far enough to bring their moisture to the western plains beyond the 98th and 100th meridian lines of longitude. During the summer months, moisture will also blow into the continent from the Gulf of Mexico, but these winds generally blow northward before curving eastward, which once again dumps rainfall across the eastern United States, but deprives the west of hardly any. As an ultimate result, when you combine all of these factors together, it adds up to there simply being less available freshwater across this empty third of America, meaning less water to drink and less water available for agriculture. Farms to the west of the 100th meridian nearly always require more complex irrigation practices, since they can't rely on reliable rainfall as much as the farms over to the east. And as a result, the farms west of the line are larger and less productive than those to the east of it, simultaneously taking up more available space while feeding less of a population base, and consequently leading to significantly lower population densities. Even the different kinds of crops grown on each side of the line are often very separated. To the east of the line, where water is more plentiful, thirsty corn is the more dominant crop chosen to be grown by farmers, whereas to the west of the line, where water is significantly more scarce, drought-resistant wheat is the preferred crop of choice instead. But most alarmingly of all, however, is the fact that it appears the line dividing the wet and dry halves of North America is increasingly shifting further and further to the east as the global climate continues to rapidly change. A century and a half ago, back during John Wesley Powell's time, when he correctly identified the 100th meridian as the approximate boundary, the line has steadily shifted eastwards to around the 98th meridian today, and it appears to only be continuing further with this eastward migration, which will begin dramatically affecting the climate of all of America's frontier cities from San Antonio in the south to Fargo in the north, which will all begin seeing less and less reliable rainfall as the century progresses, with all of the accompanying economic damages that'll entail. More and more farms within this area will begin being forced to adopt irrigation techniques, and many will fail or be forced to consolidate with other farms outright. Many will have to abandon growing thirsty crops like corn and switch to more arid-friendly crops like wheat. And all of this is even more problematic when you consider that the American West is already going through what is likely the worst drought the region has seen in thousands of years. With a serious lack of rainfall, much of the American Southwest has been forced to rely on the fresh water provided by the Colorado River for more than a century now. But for the first time in recorded history, the Colorado River is drying up. Just this year, for the very first time in American history, the United States federal government cut the water that states are allowed to withdraw from the river, with the potential for additional cuts further into the future as well. The Colorado provides the fresh water for around 40 million people across the American West, and it is already so thoroughly irrigated and pulled from that the river no longer even reaches its natural delta in the Gulf of California. All of its water is basically used up or diverted elsewhere before it can even reach it. Throughout the empty part of America, water scarcity will be the defining characteristic across the 21st century, and it of course has the potential to continue getting even worse. But all of this was predicted a century and a half ago by none other than the main character of this video himself, John Wesley Powell. You see, when Powell drew his line across the 100th meridian that divided the wetter East from the drier West, his attempt was to convince the United States Congress to take a drastic action. He warned that with the serious lack of available fresh water, the settlement of the American West was going to have to be carried out in a vastly different manner than the settlement of the East was. Development would have to be more careful, more precise, and better planned out in advance, rather than respecting the pre-existing political boundaries of the Western states that had been based on surface geography and politics. Powell argued that the West should instead be divided into areas that matched up with the region's various watersheds, which are hydrographic basins where all the rainfall collects and drains off into a common outlet, like a river or a bay. By basing the political boundaries more on these natural watersheds, Powell was arguing that the management of the area's scarce supplies of water would be more efficient and better utilized than under the current administration, where the watersheds were all divided in between the various different states, and who would therefore each have competing interests and uses over the same limited sources of water. But Powell's scientifically based proposals and warnings would go ignored by the politicians of his day in Washington, and I would argue that we have paid the price for it ever since. Water is growing increasingly scarce to come by in the West, and it's only going to continue getting worse. And the competing interests of all the states across the various watersheds here is only going to exacerbate the crisis ever further. John Wesley Powell was a geologist and a scientist, and his thinking was centuries before his time. His analysis of the American West and his conclusions were rooted in scientific thinking. And if you're anything like him or me, then you're probably just as curious about why our planet and reality works the way it does. But the world is a complicated and sometimes difficult to understand place. Science and math serve as the primary tools in helping us understand our complicated reality. But for myself, and perhaps for you as well, science and math are each subjects that have never come easy and may even seem impossible to truly grasp at times. I struggled with learning science and math for my entire life until I discovered Brilliant. And now, through them, everyone, regardless of prior knowledge or ability, can get a little dose of scientific learning every single day. Whether you're looking to learn something completely new or you're just trying to brush up on a few subjects, the best way to learn anything is by actually doing the work yourself. And there's no better place to do that than on Brilliant. You see, Brilliant is an interactive STEM learning platform that helps you learn concepts by working through them in a visual, hands-on, and easy-to-comprehend way. And you can get started right now on any number of courses, from more basic but fascinating concepts like the physics of the everyday and casino probability, to more advanced, cutting-edge fields like computer science and algorithms, to chemistry and electricity, and so much more. Regardless of which subject you choose to learn about, you get to learn at your own pace, you can learn on the go with their mobile app, and most importantly of all, you get to actually enjoy the rewarding process of learning awesome new things about our reality. And if you ever get stuck on a particular question, Brilliant never punishes you or impedes your progress. Instead, they'll give you an in-depth explanation to guide you further along your learning path. And best of all, you can try out Brilliant right now for free with the link down in the description or by clicking this button that's here on your screen right now. And the first 200 people to sign up will also get 20% off of Brilliant Premium for an entire year. And as always, thank you so much for watching.